This is 4.3.1 population growth, equations of separable equation. Let's just look at the model for the population growth. The population here may refer to the populations of a town or the populations of bacteria. And we assume that under ideal conditions, that is, your population has the unlimited environment, adequate nutrition, absence of predators, immunity from disease, then the growth of the population is proportional to the size of the population. Which means that you can use these differential equations that is dp dt equal to kp. The dp dt here is referred to the rate of growth of the population. The k here is referred to the population constant, and the p here is the population at the time t, and t here is referred to the time. So let's just look at the example 1. So the population of a town grows at a rate proportional to the population present at time t. The initial population is 2,500 and the population increases by 10% in 12 years. Find an expression for the population at any time t. What will be the population in 30 years? And first of all, let's just gather the information from this example. The first information that we could get is the initial population is 2,500. The initial here means that your time is actually equal to 0. Your t is actually equal to 0. And it says that the population is 2,500. So I'm going to use the symbol P to denote the populations. Okay, so the population is 2,500. So the way we're going to write is as P. Okay, the P stands for the population. P at the time equal to 0. We're going to put the time inside the bracket. Okay, so the time equal to 0 is equal to 2,500. And let's just look at the next information that we have. So the next information that we have is it says that the population increases by 10% in 12 years. So in 12 years, so it means that your t is actually equal to 12. Okay, and the population increases by 10%. Population increases by 10%. So now this is referred to your p, your population. So we're going to write p at t equal to 12, at the time equal to 12, is actually equal to the initial, okay, 2,500 plus with the 10% multiply with the 2,500 and we have 2,750. Now we gather two important information. So let's just look at questions. So the question says that find an expression for the population at any time t. So when we say an expression, it means that they ask us to find a mathematical equations for this population. So for B, what will be the population in 30 years? So in 30 years means that your t is basically equal to 30. Your t is actually equal to 30. And the way to write here for these questions is actually the population stands for the P. So we write P 30. The population, okay, the population at time equal to 30 is equal to something that you are looking for. We put a question mark. Now we have gathered the information from the example 1. Let's just begin to solve this example by using the differential equations formula. That is the dp dt equal to kp. So now let's just solve it by using the technique that we have learned in topic of the separable equations. We're going to separate this into two different parts. Okay, we're going to bring the p here to the left hand side just that it's together with the dp. Okay, so what you observe here is the k and p is actually having a relationship multiply. We'll bring it to the left hand side, it will become divide. Okay, so it means that you will have to bring this one to the left hand side, it will become 1 over p, and we're going to have the dp together at the left hand. Okay, How about the right hand side? So right hand side, you have to bring the dt to the right hand side. Okay, just set it together with the k. We're going to keep the k at the right hand side, and it is together with the dt. Okay, so once we do that, you can see that I basically have the variable p with the dp at the left hand side, and I have the constant, the k, with the dt at the right hand side. So you have two different parts. Okay, so now we're going to do the integration. So let's just integrate both sided. So if you integrate both sided, okay, for the left hand side, if you integrate 1 over p, so we have ln p. And how about the right hand side? The right hand side, you integrate with respect to the time, okay, to the time. The k is a constant here. So if you integrate it, so we will have kt plus c. Okay, then the next thing that you have to do is you have to add the exponent to both sided. So let's just add the exponent to both sided. That is what we have for the next line. And if you look at the left hand side, the exponent and the ln, basically you can simplify it. Okay, if you simplify this one, so basically means that the ln and the exponent you can cancel. So for the left hand side, you have the p only. And let's look at the right hand side. The right hand side, what we have here? Okay, for the right hand side, so you have to split into two exponents. So basically, you're going to use the technique that you have done in the index. Okay, for instance, you have this one, 3 to the power of x plus 7. Okay, so this is basically you can split it into 3 to the power of x multiplied with 3 power of 7. So you're going to apply this one into here. So it means that your exponent can split into two exponents. So the first exponent, that is e to the power of kt multiplied with the e to the power of c. And okay, if we look at here, the e to the power of c here is actually a constant. Okay, the c is a constant. Exponent to the power of constant is actually another constant. So I can change this one into another alphabet. Let's say a to denote the constant. Okay, and we have the next one. Okay, let me erase this one. Okay. Okay, what do you see here is basically I have an equations p equal to a e to the power of kt. So in these equations, you have two parameters that you have to figure out. That is parameter a, you have to figure out the value, and the parameter k, so you have to figure out the value. So let's just name this one as number one, equation number one. So how are we going to figure out the parameter value for the a and the k? So that is from the information that we obtained just now. Okay, so let's look at the first information, that is the p at time equal to 0 is equal to 2500. Okay, we're going to substitute these informations into equation 1. So it means that, okay, that is your population is 2500. Okay, your population is 2500. We will substitute here p is 2500. Okay, and then your time is actually equal to 0. So we will substitute the time equal to 0 into here. So you have the next line. Now, k multiplied with 0 will give you 0. So e to the power of 0 is actually 1. So for the right hand side, you will have only a. So your value of a is actually 2500. So now you have obtained the value of a. Okay. So substitute your a into your equation number 1. So let's substitute into here. So this is your value of a is 2500. Now this is the next line. Okay, so we name it as equation number 2. Basically, you can see that I managed to find the value of parameter a. So since I have managed to find the value of parameter a, so I don't need this equation. I don't need number 1 anymore. I just focus on number 2. So the next task that you have to do is you have to figure out what is the value for this parameter k. So how are we going to obtain the value for this parameter k? That is gathered from the, we can get it from the information number 2. So your information number 2 says that at the population at the time equal to 12 is actually equal to 2750. So we're going to substitute this one into your equation number 2. Okay, so we'll substitute into the equation number 2. So this means that your population is 2750. We'll substitute in here. And your time is actually 12. Okay, so we substitute here. Okay, let's just simplify it. Okay, we can bring this 2500 to the left hand side. Okay, so right. Okay, so we have 1750 divided by 2500. For the right hand side, you will have this one e to the power of 12k. Okay, so for the left hand side, you will simplify it. So if you simplify, you have 11 over 10. Okay, for the right hand side, we have the same thing. Okay, now we're going to deal with the exponent. So I'm going to omit the exponent. So the way to omit exponent is actually simple. You just have to add that ln to both sided. Add the ln to both sided. If you add the ln to both sided, okay, so let's just focus on the right hand side. Okay, what happened to the right hand side? So you can see that basically I have the ln and I have the exponent. So if I have that means that basically this is actually simplified, where this is actually equal to 12k, where the ln and e. So this is actually equal to 12k for the right hand side. Okay, and then you can simplify it some more. Okay, you can bring the 12 to the left hand side. You can it becomes y. Okay, and simplify it, then you have the value of k. Okay, now you obtain the value of k. Substitute the value of k into your equation. Okay, so substitute into equation number 2. So if you substitute into equation number 2, then you will have this one. Okay, so now you can see that I managed to find the value of parameter k. So this is basically the answer for your question 1, question A. That is the mathematical equations for this population anytime. Okay, so this is the mathematical equations that we are doing. Okay, now we have the second questions, that is population at time equal to 30. Okay, so now we're going to use these mathematical equations that we obtained just now to make the predictions. Okay, so just take this. Okay, we're going to substitute this one, okay, into your equation number 3. Okay, so this is your mathematical equation for this population. We're going to substitute into this equation. So this means that you're going to substitute at the time equal to 30. Time equal to 30 into these equations. Let's just substitute it. We have the next line. Okay. And use your calculator to get the value. Then you will have 3172.4047 individuals. Okay. So this means that what? This means that we could estimate that, okay, the population in 30 years will be around 3,172 individuals. Okay, let's just look at example 2. So the number of certain type of bacteria increases continuously at a rate proportional to the number present. After 3 hours, the number of bacteria is measured to be double. So determine the time necessary for the number of bacteria to quadruple. Okay, so first of all, you have to identify the initial populations. But unfortunately, we do not have the information we get the initial populations. So what you have to do is we know that when you're talking about initials, it means that your time is actually equal to 0. Okay, and if we say the initial populations, that is the population at the time equal to 0. Okay, and because we do not know the informations regarding the initial population, so what you have to do is you let it equal to some constant. So let's say peanut. Okay, so because the information is not given, so we let it equal to some constant, say peanut. Okay, then only we look at this 3 hours. Okay, so it says that after 3 hours, okay, if 3 hours means that your time is actually equal to 3, and it says the number of bacteria is measured to be double. Okay, so means that the populations of the bacteria, the population at the time equal to 3, the time equal to 3 is measured to be double. Okay, so double means that 2 times. Okay, double means 2 times. 2 times of what? 2 times of the initial. Okay, so we have 2 times the initial, so that is equal to 2 times of the initial. Okay, so now we have gathered 2 important informations. Now let's just look at the questions. Okay, so the question says that you have to determine the time necessary for the number of bacteria to be quadruplets. Okay, so when we're talking about the time necessary, okay, it means that they ask you to look for the t equal to question mark. Okay, You have to identify the time, so we let the t equal to some question mark, and for the number of bacteria to be quadruplet, so means that the population at the time t, so population at the time t, so pt. Okay, to quadruplet. Okay, what does it means by quadruplet? Okay, quadruplet means 4 times. Okay, 4 times of what? 4 times of the initial. Okay, that means that 4 times of the initial. Then we have pt equal to 4 p naught. Now we have gathered the information for the example 2. So let's just begin to solve this example by using the differential equation. So now what you have to do is you have to drag the p to the left hand side such that it's together with the dp. So when you drag the p to the left hand side, it becomes 1 over p together with the dp, and drag the dt to the right hand side such that it's together with the k. So we have k dt. Then add the integration to both sided. Okay, so we integrate both sided. And if you integrate both sided, for the left hand side, you have ln p. For the right hand side, you have kt plus c. And add exponent to both sided. So add the exponent to both sided. If for the left hand side, if you add the exponent, so the exponent and the ln will basically cancel. We just leave p only for the left hand side. For the right hand side, basically you can copy back. So we have this one. So instead of writing the step of adding the exponent, you can skip this step. So you can skip it. So you can direct it from here to here. Alright. And now for the right hand side. So for the right hand side, the exponent you can split into 2 exponents. So you have this one. And let's just observe here. So you have e to the power c. C is a constant. E to the power c is also a constant. So you can replace it with another constant, let's say a. So we have the next line. And same thing here, I actually can skip this step. So just skip it. So we have from here to here. Okay, now let's just name this one as equation number 1. Okay, our next task is to figure out what is the value for the parameter a and what is the value for parameter k. So how are we going to figure out the value of parameter a and k? So that is through the information that we have here. So we're going to use the first information that we have here. That is this one. P0 equals to P naught. So we're going to substitute P0 equal to P naught into your equation number 1. So means that your population is P naught. So substitute here with P naught. And then your time here is actually 0. So substitute the time here with 0. Then we have the next line. So we have k multiplied with 0 is 0, e to the power of 0 is 1, so then we will have a equal to the p naught. So substitute your a equal to p naught into your equation number 1. So means that a is p naught, so substitute here. Okay, so when you substitute here, then we have the next line. So means that we have settled with the parameter a. So let's just name this one as the equation number 2. So we can just leave the equation number 1. We don't need it anymore. Just look at the equation 2. Okay, so now we need to figure out what is the value for the parameter k here. So how to figure out the value of the parameter k? That is the time we're going to use the second information that we have here. That is this one. Okay, so we're going to use this one. Okay, so let's just substitute this one into your equation 2. So it means that your population is equal to 2 p naught. Okay, we'll substitute here. And your time here is actually 3. Okay, so let's substitute here. Okay, so you can cancel. Okay, you can cancel the p naught. You basically can cancel the p naught here, cancel the p naught here. So I have the next one. Alright, and then you have to add the ln to both sided. Okay, to add the ln to the both sided. Okay, and for the right hand side, okay, the ln and e basically you can cancel. If you cancel, the thing that remains is actually 3k only for the right hand side. Okay, for the left hand side, we just copy back. The same thing here, we actually can skip this step. We can skip this step. So if we skip this step, I will just directly from here to here. Okay, then let's just continue. Okay, so you can bring the number 3 to the left hand side. It can divide. Then we have the value of k. So your value of k is 0.2310. So once you know your value of k, so let's just substitute it back to your equation number 2. So substitute the value of k into here. So then you will have the next line. That is this one. So this is your equation number 3. Your equation number 3 is basically the mathematical equations for the bacterial population at any time t. So we're going to use these mathematical equations to help us to answer these questions. Okay, so we are interested to know when will the population become 4 times of the initial. Okay, so how are we going to do that? Okay, so we're going to substitute this one into your equation number 3. Now means that your population now is 4 times of the initials, 4 p naught. We're going to substitute the 4 p naught into here. So we have 4 p naught into here. Okay, the time is actually unknown. We do not know about the time. Okay, so it means that you have to copy back the right hand side. We have the right hand side. The same thing, we're going to cancel the p naught here. Okay, so we're going to cancel the p naught and p naught here. So if we cancel, then we have the next line. And once we have the next line, and we're going to have add the ln to the both sided. Okay, if you add the ln to both sided for the right hand side, the ln and e basically you can cancel. If you cancel the ln and e, the thing that remains is just this one. Okay, same thing, we can skip this step. So let's just skip this step. So we just directly from here to here. So rearrange it, then you will have the value of t. Okay, so it means that the number of the bacteria is actually takes 6.0013 hours to quadruple. Okay, let's just look at the example 3. So in 2019, the world population of humans was estimated to be about 7.5 billion individuals, and the annual rate of increase was about 2.5%. If this rate of increase remains unchanged, how long will it take for the world population to triple? What will be the estimated world population be in year 2050? So let's just extract the information from this example. So it has mentioned about the year 2019. So the year 2019 is our initial. So that is your time equal to 0 here. And the population at the time equal to 0, okay, P0 is basically equal to 7.5 billion. Okay, the next thing that we have here is it's mentioned about the annual rate of increase. So the annual rate of increase was about 2.5%. That is actually referred to your K. Your K is 2.5%. Okay, change this one into decimal. Then we have this one. So let's just look at the questions. So if this rate of increase remain unchanged, how long will it take for the world population to triple? It's basically want to know the year, in what year. Okay, means that the time is actually a question mark. Okay, so the population will be triple. Okay, so when we are talking about triple, means that it's actually 3 times. Okay, 3 times of what? 3 times of the initial. So means that your population at the time t, okay, is equal to 3 times of the 7.5. Okay, so 3 multiplied with 7.5, let's give you 22.5 billion. Okay, let's just look at the next questions. Okay, what will be the estimated world population be in year 2050? So year 2050 means that your time is actually equals to 2050 minus 2019, that is give you 31. So we are interested to know what is the populations at the time equal to 30. Okay, so you can write P30 equal to a question mark. So once we have gathered the information for the example 3, let's just begin to solve this example by using the differential equations. Okay, so if you look at this example, it's actually slightly different from the previous example because you know the value of k. Your value of k is actually 0.025. Basically, you can substitute your value of k into here. Okay, so then we have the next line. Okay, now what you have to do is you have to use the technique of separable equations. You have to bring the p to the left hand side so it's together with the dp. So for the left hand side, you have 1 over p dp. And for the right hand side, bring the dt to the right hand side so it's together with the 0.025. Okay, then integrate both sided. Okay, if you integrate both sided, for the left hand side, you have ln p. For the right hand side, you have 0.025 t plus c. And now add the exponent to both sided. Okay, we have this one. Okay, so focus on the right hand side. For the exponent, you can split into two exponents. So we have this one, and e to the power of c actually is a constant, so you can replace it with the another constant, let's say a. Then we have the next line. So let's just name it as equation number 1. Okay, so if we focus on here, basically we just have to figure out the value of parameter a. Okay, so you just have to figure out the value of parameter a. And how are we going to find out the value of parameter a? That is through the information that we have here, that is p0 equal to 7.5 billion. Okay, so we're going to use this information. So let's just substitute p0 equal to 7.5 into your equation 1. So it means that your p here is equal to 7.5. So substitute p equal to 7.5. And your time here, your time is actually 0. So you substitute 0 here. So then you will have your a is actually 7.5. Okay, so now you know your value of a. Substitute your value of a into your equation 1. Okay, so if you substitute into your equation 1, then we have this one. Okay, so let's just name it as equation 2. So your equation 2 is basically the mathematical equations for the world populations at any time t. Okay, so now we're going to use these mathematical equations to answer the questions. Okay, so let's just look at the first questions. Okay, we are interested to know the time. Okay, when will the population become triple? That is become 22.5 billion. So the way to do is you have to substitute the p t equal to 22.5 into your equation number 2. So substitute your p equal to 22.5 into here. Okay, and the t is actually unknown. Okay, so we just copy back the right hand side. So now, okay, so you have to manipulate it. Okay, so you have to bring the 7.5 to the left hand side. So we have 22.5 divided by 7.5, that is give you 3. Okay, we have the exponent on the right hand side, and then you add the ln to both sides. Okay, and bring this one to the left hand side, we can divide. You have ln 3 divided by 0.025, and you have the value of t. Okay, so it means that, okay, it will take 43.9445 years for the world population to triple. So we have done with the first questions. So let's just move to the second questions. So the second question is asked P31. Okay, so it asks about the P31. So the population at the time equal to 31. So what you have to do is you're going to substitute the P31 into your equation number 2. Okay, so it means that you're going to substitute your time. Your time is 31 into here. Okay, so you substitute. So we have this one. Okay, use your calculator. So we have the population. So the populations at the time equal to 31 is 16.2794 billion. Which means that in year 2050, the estimated world population will be 16.2794 billion individuals.